Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about Advanced Driver Assistance System. So let's dive deep into it. So basically today's topic is ADAS. Now why I'm doing this? Well, somebody paid a lot of money. Basically at the rate PP_Noah paid a lot of money for this. So I'm covering this. So we are talking about ADAS. Now be mindful, the biggest headache with this system is that it's an umbrella term. It's like saying fruit. Does not mean anything. Does that mean guava? Does that mean a potato? What does that mean? Stuff. What does it mean? You say apple, that's a exact specific thing. Fruit, it could be anything. So ADAS is an umbrella term. It's pointless. Now, car tools that are allowed for safer driving, that's the aim of it. Meaning tools that you put in your car that helps to drive safely. It's not going to drive the car for you. It's just going to improve your odds of survival. Its only job is safety. It's not there to control anything. It's not there to do anything other than to control the vector of safety itself. Now, why is that? Well, here's the deal. People have countries. Countries have data points. That data points are generally national transportation bureaus, and they collected all the data for thousands of boom events, and outcome is always the same. 99% of the time it's a oops event that causes an accident. It's a rarely movie kind of scenario or equipment failure. Now again, let that be very clear. It's not that it does not happen, but in grand scheme of things, like from a national point of view, you will find majority of oops event causing issues. Now unfortunately, even though these are oops event, they may end up causing fatality. So people do understand that if we can stop or even reduce this oops event, the life saved would be exponential. So people are like, let's do this. So why this so many oops event happen? Well, primary reason is lack of attention. Meaning we human brain requires novelty to stay functioning. Meaning if you're driving on a straight road and if it's a very empty road for a very long time, yeah, you're gonna crash. It's a weird thing, but you cannot drive on a boring road for very long. Heck, there was a bridge made on a sea that was very long, and engineers were like, yeah, if we make it flat, everybody's gonna crash. They made it S-curve, so people have to constantly drive. Please tell me which bridge I'm talking about. But that's the whole point. Our brain does not like monotonous things. And sometimes you could be just tired. Like you are a human, you could just boom. So in those sort of scenario, if we can just have something to safeguard against those oops event, a lot of life would be saved, a lot of property damage would be averted. Good thing. And again, it does not require full AI with full self-driving and stuff. So that's what we are talking about, ADAS. So what about the input? Again, car does not know what's going around unless you give it eyes. So first thing, car needs to see the world in real time, meaning it cannot rely on map or Google Map or things of that nature. It needs to see what's going on right now. So we start with camera. Now let's assume you are Mahindra and you're going to, hey, camera makers, let's give me some camera sensors. So what will be you looking for? You'll be looking for high dynamic range. Generally, that means monochromatic camera sensor, meaning you do not have a color filter on top of a black and white sensor. And yes, there is no camera sensor that is technically colored. All camera sensors are black and white. You put a color filter, so you get colored data out of it. So you remove that filter. Now photon efficiency improves, and now you have much more dynamic range. You can see much darker thing clearly and much brighter thing without blowing out. So that's what we call dynamic range. Same sensor, like same CMOS sensor made from Sony or Samsung. You can just remove the color filter. Again, you have to place a bulk load of order. You will find higher dynamic range. Generally 1 to 2 stops of extra. So generally they pay for that high dynamic range because many times car would be driving into the sunlight and you do not want your camera to be blinded. So that's like primary requirement number one. Second, high FPS. Cars can be driving fast. Now in India, we do not drive that fast. So we generally start with 100 kilometer, barely go to 150. So that's it. But again, what if your car is supposed to be sold in a German Autobahn? In some scenarios, people do get carried away and they're like, what if we cross 300? So your camera refresh rate has to be fast enough to actually keep up with that. So basically it needs to see the world in slow motion while you are traveling at 300 km per hour. So yeah, high FPS is a primary requirement. Another is color. Now, do they need colors? Majority of the time, no. But sometimes they may have one color camera just to read some signs and some worn out things. But it's not necessary because be mindful, based on the country, there's a law. Like a red symbol has to be in this exact shape. The red light has to be this exact same position above the green or below the green. It will not change. And if it has changed, you have bigger issues. So generally, and again, you can also train. Red light, computer assume this gray shade to be a red light. You can train it also. So generally it's not done, but it can be done if you need to. So Tesla rely on that part only. However, you must have seen the problem. It has the same problem as human eye. While you can have a better eye, you have the limitation that what if fog happens, what if rain happens, things of this nature, poor visibility. Yeah, your camera is not that good at that point. To solve that, we have radars. Now, be mindful, radars that are used for planes, they are very long-range radars. Those are long puppies. The wavelength are long. You must have experienced this in your household when you have Wi-Fi routers. Routers generally come with two frequencies, even if you have a cheap one. So they have 2.5 gigahertz and they have 5 gigahertz. Now, 5 gigahertz gives you more throughput, but 2.5 gigahertz goes further. So even outside of your house, you can connect to 2.5 gigahertz. Same goes here. What if you have a radar? The wavelength is huge. It's not going to tell you things, okay? It's not going to give you a high enough fidelity feedback to do anything. It's designed for planes. So we need to use high frequency. So you can like, okay, I tell this car is 7 meters away. I tell this car is 5 meters. So your wavelength has to be tiny. How tiny? Introducing millimeter wave. So millimeter waves are basically from 76 gigahertz to 81 gigahertz. This puppy has two benefits. First, it's millimeter wave, meaning with millimeter precision, almost 1 millimeter to 2 millimeter precision, you can tell this car is freaking 4 meter away within a millimeter. I'm saying this is 4 meter away, that means it's a freaking 4 meter away. You have absolute, it does not give a damn about weather or environments or things of that nature. So you have very high fidelity. It's like, I'm saying this is this far, it is exactly this far. And it also gives you exact measurement. It's not guessing, it's not calculating, it's not like our eye calculation and all that. No, it's saying it's absolute. So that gives you a very good system. And another benefit is that higher the frequency, the lower distance it travels, meaning your car can be screaming. It's like, bah! And the other car that is on the other end will barely hear it. It attenuates too quickly. Higher the frequency, the quicker the attenuation. So other cars are like, who cares? So radar is generally used with millimeter waves, 76 to 81 gigahertz. And that's the missile lock radar. And then you have another version, that is LiDAR. Again, same technology, but instead of millimeter, nanometer. We basically switch to optical frequency. Now, this puppy is accurate, high fidelity, and super awesome. Like practically one of the best tools that we have for saying that this is a 3D space, this is the goddamn 3D space, this puppy. Now, again, you can see radar does give you some idea, but this gives you a 3D sphere from one point. And if you have two LiDARs, let's say on the edges of the car, you can see things. Like you have a 3D voxel space where it's like, I know what this car is. I know how far this is. I know how far it's traveling. It's very good. And some LiDARs are so advanced that it can analyze the reflectance, basically polarization of return light. So it can tell, hey, your road has ice, my man. Hey, there is oil on the road. Hey, yeah, you have this sort of foggy reflection. Again, extra data points. So LiDAR are generally one of the best tool. Now, if you want a company, you do not want to scam your audience, you generally will have all three: camera, radar, and LiDAR. So any company that is claiming level 6 self-driving or legally autonomous driving, they are using all three. One company that is trolling, I have no idea how the heck they are trolling American government, but they are, it's Tesla. They're only relying on camera, and that's why so many people have died, because again, camera makes the same mistake as human eye. Sometimes this misinterprets, and again, AI has the same rule as computer: garbage in equals garbage out. While radar and LiDAR, if both are there, you have absolute silence. This is a fire truck. Thou shall not go ba-bam into the fire truck. But Tesla's car, I do not understand what I'm seeing. I do not understand how far it is. Ba-bam, people dead. Happened. Not a joke. Happened. So these are the inputs. You need at least 3 of them, or at least 2. If your company has only one, run. So camera, radar, LiDARs are a bit expensive, because again, the day humanity cracks solid phase LiDARs, meaning the sensor part we are sorted, sensor is solid state, but we have a spinning mirror that spins the laser. What we need a solid diode array, which has phase shift, basically how your 5G antenna is. So you can have a phase array like this, and laser can go, wee. That will solve all the problem. No company has cracked it yet. People are working on it. The moment the company cracks it, that company will become the OEM daddy, and 5 or 6 years from that point, we will have self-driving car. Reliable, high quality, trust yourself, and this car will not go inside a fire truck, that kind of safety. So these are the input puppies. So what actions do it? We got the vehicle, the input, what it can do. It can in principle drive, but it's not meant to. By law, it's not meant to. By cars liability points, it's not meant to. It can only guide and do what we classify as emergency intervention, meaning if it intervenes, it has to show in court of law where it's like, my not intervening would have caused more harm, so I intervene. Basically, other than that, it will not do anything. So it has to do that. So the first generation of this technology was automatic braking in cases, because our eyes are not quote-unquote property. It's not LiDARs. We do not tell, that camera is 7 meters away from me. I can know exactly my speed. I know how quickly I'm going to apply the brake. Yeah, car knows that. Car knows that. Car knows its mass. Now, like how the heck car knows it? It knows how much energy the engine is putting out and how quickly you are changing. Just by acceleration data, it can get a very good mathematical assumption. It's like how the roads are reacting. So it's like roads are a bit too slippery, my man. The temperature is too cold. So it will have a good lookup data where it's like, yeah, the braking distance has been increased. So it knows. So automatic braking was the first thing we trusted this puppy to, and it worked quite well. Because here's the deal. Many times the worst thing happens is fog of thought, meaning you're driving, especially in long drive, and you're just like, you just get lost, right? You're driving, you're active, but your brain goes into idle mode. You're not processing information. Now you can slowly creep into a car, and that car applies brakes. Now, again, you are so lost that you do not see that change did not get registered. Your car is going too close. Now, this puppy is like, bruh, I think you're close. It will start screaming. It's like, bruh, you're getting too close. And then it will scream again. Generally, it screams at T2, T. And if you do not do anything, it's like, bro, I'm taking over. It applies the brake. Aims it. So that's the whole point. Automatic braking in case. Because again, if the radar tells you, the camera tells you that you're going to hit something, you're going to goddamn hit something. And again, that's why camera is not trusted upon real, like solo thing. Unless you are Elon. In most scenarios, like, dude, you have to have a radar as a fallback. You have to have LiDAR as a fallback. And if all three are telling there is something unpassable in front, apply brakes. So automated braking system, that's the first line of defense you have. Then you have another system, automatic speed, meaning this puppy, instead of controlling your brakes, it also controls your throttle. And then it has lane keeping. Now, cruise control, lane keeping was a known system, where it's like, generally cruise control simply means it locks your throttle based on the speed requirement. Meaning, if let's say you are driving on a highway and the highway has 80 km/h speed limit, you can set your car's cruise control to 80 km/h. And instead of straining your leg, you're like, hey, let's just drive. The car is like, I got you, fam. I got you. I know the engine throttle setting. I know all those jazz. You do not worry about it. And given the fact that throttle is no longer physical connection, is drive-by-wire, so computer's like, I got you, fam. I got you. It keeps engine precisely at that. So you do that. And because again, we have a motor in our power steering, so that's a very easy function to, it's like, hey, power steering, brah, turn the steering wheel. So the hardware is already there. So if you have the input, control hardware was already there. So throttle is already drive-by-wire. Brake is the only thing that does not have drive-by-wire. So they need an actual actuator for brake. Other than that, everything is drive-by-wire. So again, steering does have a mechanical connection, but that's in case of a failover of a motor of that power steering. So automatic speed and lane keeping, meaning it studies the lane markings, and if you start to drift, which again, it will happen because you cannot pay attention to boring things. If the car is like, I got you, fam, it will slowly start to warn you. And if you do not do anything, it will either apply brakes or bring you back. That depends on the car manufacturer and the settings you have set. So these are the two things. Now here's the deal. You may think, okay, if it can do this much things, it can technically drive. Well, yes. Practically, factually, yes, it can drive itself. And again, especially if you're just going on a highway, in principle, you can just go on a highway, trigger this puppy, and this is like, then you just sleep. While yes, it can be done, and some people did trick this puppy, all the modern cars have detection of the steering wheel. Meaning, if you do not hold your steering wheel, it will scream. It's like, brah, what are you doing? And if you do not do anything, it will apply an emergency brake. So it will jerk you. And if you still do not do anything, it will trigger the emergency light and then slowly park somewhere. And then it will call the emergency service. That function is dependent on the country. So it can say, hey, this is an automated message from this car. The car has like a decapacitated or something like that owner. Again, it's a whole protocol for this. So people can come and rescue. So automation can be done. And again, that's why the moment you leave the steering wheel, it will be like, brah, no. Another aspect, some of them have camera and infrared sensors inside. So if you become lethargic, it's like, the car is like, brah, how about a brake? How about a tree brake? And you're like, what if I ignore it? Car is like, nah, bro, you will not sully my reputation, my man. You're going to take a break, or I'm going to make you take a break. So car is like, I get you, fam. So these are the actions they take. Apply emergency brakes, keep your lane, keep your speed without too much hassle. And if you are becoming lethargic, it will not allow you to drive. And if it becomes basically any situation where it's like some serious issue, it could call for help. So these are the actions. Generally nothing too major, basically basic controls. And it's just designed to stop that oops moment. Where it's like, oops, I did not see that car in my blind spot. Again, this does not have a blind spot because there's cameras everywhere, radars everywhere, and generally supposed to have a 360 dome view with precise feedback loop. So it's like, bruh, I got this. I know there is no, basically blind spot. So these are the actions they take. Now, once you talk about the actions, you must have heard about these levels, because again, I specified this term is an umbrella term, does not mean anything. One company can give you almost self-driving, another company is like, I just have fancy brake. So in those sort of scenario, in principle, the car can drive itself, especially on higher ends of the technology. It's just that for safety and for legal reasons, it's not allowed to. And level 1, again, these levels are not very clear cut, so I'm simplifying. Level 1, only brake focus. Their primary focus is I will take over the brakes and I will do my best to slow accident. Even if you're driving, let's say 120 km per hour, and something bad happens, and it will react faster than you can react, it will try to slow down. And any kilometer per hour you can remove from your collision will reduce the impact energy, and that is significant. Even if you can only slow down, let's say you are traveling at 100 km per hour, but you can only slow down 95 km per hour, that's significant. That is very significant in terms of energy saved. So you want that energy to be saved, so collision does not cause too much damage. And if it's very significant, let's say it detected faster, it applied the brakes, it went all out on it, and it slowed down from 100 kmph accident to 50 kmph accident, it will be minor inconvenience at that point. So level 1, that's the whole point. Level 2, it can touch accelerator, meaning it's like I can drive you faster. But again, they are designed to be very conservative, very methodic. So meaning it will not just go wing wing. It's not Tokyo drifting. It's very methodic. And if you try to do lane changes without giving a signal, it's like brah, what are you doing? And if it detects a car in the blind spot, it will slam the brakes. So it will not cause a collision, so to say. That's level 2. Now level 3 is what we call death trap. Unless you are an Elon fan, you should never ever buy a level 3 car. Level 3 car does this, and yes, people have died, and yes, more than one. Unfortunately, the number is very high, because still this is the best infographic I have found about it. One is 0 is nothing. It's a Model T. There is no controls. Cool. Level 1, a little bit of driver's emergency braking. Level 2, it can do a little bit of like lane correction and all that. Level 3, conditional automation, meaning if it's in the right zone, basically a interstate highway or things like that, it's like I can drive it. Yeah, that's the worst vehicle ever. And again, countries are working so they can ban it. The problem is that level 3 company claims that it's a self-driving, but you're supposed to be able to take over. And if you know human brain, that's not how it works. Because here's the deal, our brain has a lag. If you're seeing, you're driving, then the lag is tightened. You know, like my car is doing like this. Okay, I got this. Like there is a feedback loop. You're good. Now imagine if you're just doing like this. Again, car is driving itself, so you're just chilling. And then car just screams at you. It's like, bro, take over. It's like, what the hell I'm supposed to do in 1 second? It can't. So many of the collisions that happen in Tesla is like, hey, what if we F the customer? So what they did is like, before the crash was here, before computer detected, it's like, oh, I'm gonna do something that I cannot recover from. Disable autopilot. Oh yeah, people crashed on manual. It's like, how the heck you got it there? Now, to be fair, there is 3% hope in USA left, is that somebody is like, hey, can you please give us last 30 minutes of driving data? Because again, that's why I say, like, human psychology wise, it is beyond stupid how the heck level 3 was even allowed. It should not have been allowed. You cannot take over something that's like, imagine somebody else is driving. You know when they're gonna switch, then it's hard and scary. Imagine you're just like lost in your thought, is the car, like, what the hell? It's literally cruel. And again, that's why Germany is like, no, do not call this self-driving. And again, they had to fix the idea, because in the early days, they actually allowed people to sleep. I'm not joking, they allowed it. Now they're like, yeah, no, you have to keep your hand on the steering wheel, and it screams at you if you're not looking at it. Basically, third level should not be even allowed to exist. Level 4 is like, okay, car is responsible for you. Flat out. You are not responsible, car is. And all it has, like the steering and accelerator and all that, they will be disabled. And level 5, they do not even have those. So level 5 is basically, it's just a pod. Level 4 is basically a pod with manual failover. Failover as in like, you have to disable it. It will not just like, oops, just 1 second before accident, I'm gonna F you. No, that's not there. So level 1, good start. Level 2, really good control. Level 3, run away from this. So these are the levels into it. Again, that's why people are so angry when the judge called it, oh, it's just puffery. People are dying because of your goddamn puffery. So level 1, good. Level 2, good. Level 3, run away. Level 4, good. So what are the problems in this system? Well, again, I'm specifically talking about India. The rules and regulation are very sloppy in this. So problem is, there is no clarity on what it is, how it is. Even though the word has been used by at least 4 or 5 car companies, you do not know what you're getting. Because if I say ABB, anti-lock braking system, ABS, you know what you're getting. Every car, you know what ABS means, how it behaves, how it works, all of that is known. In car, again, how the hell you gonna talk about, oh, it has advanced features level 2? It's like, what the hell that means? Like, think about it. Like, from a common car point of view, it's like, do you know what level 3 is or what level 2.5 means? Like, no, of course not. And do you actually gonna read a goddamn manual? So that really does not make sense. Again, that has to be a government job. That's why when you have ABS, it's a goddamn ABS. So power steering is a power steering. So how and what of these things, umbrella term should never be allowed to reach public use. It has to be like, okay, this is what we are selling you. It cannot be like, oh, this is this, because again, person going from one car to another car, they may downgrade without even knowing, and then they may have extra faith in their vehicle because again, last vehicle did awesome things. Second vessel is like, bam. You're like, what the hell? I thought it had this. So again, that's a flat out. Companies want to do this. Company wants to F you, but that's the whole point of electing a government. Government should be like, what the hell, man? What the hell? So there has to be a clear-cut growth. Another aspect is in Indian market, majority of them have off button. What the hell? And yes, I mean emergency braking has an off button. What the hell? When was the last time you saw any off button on anti-lock braking system or any that sort of braking system? It never supposed to come with an off button, because what's the point? It's like that part really confused me. Why the heck it has off? And again, imagine this way. Let's say a father buys the car, he turns everything on, and he's completely driving, because again, he's a bit older and he's driving cautiously, cool, awesome. And then his son gets in and is like, okay, I'm going to disable everything. I'm going to go YOLO mode, ludicrous mode. And he does all the fun back, brings the vehicle back, father gets in. And again, he has a bit of faith into it, he's a bit like relaxed into it, and car just bams. It's like, what the hell? Oh, I forgot to check. And company's like, your fault, you disabled it. So imagine your car having a function of like how to disable airbag. So I fundamentally do not get the idea of having off button in this sort of settings. And having tolerance setting, meaning how close it allows you to get to a second car before applying brakes. Yes, there is a control setting for that. What the hell? Why the hell? Like, you know the car mass, you know the car engine's performance, you know the braking performance. Test it on a wet road, test it on a dirt road, test it on 100 configurations, and you get an absolute data. This is the worst case scenario. Create a bit of buffer zone, and that should be your braking zone. The end. Like, this is the worst case scenario. We're gonna make sure that you are well safe beyond it. And it's like, okay, that gives an extra buffer. Cool. If person is driving fully aware, they take over, no problem. If they are not, we will not take any chance. Again, tolerance setting should not be a thing. It's like, you know the car engineer, like what your car is, how it behaves. And again, computers are good enough nowadays where it can like, hey, air temperature is cold, road is behaving bit slippery. Yes, it can detect torque differential. So all of those things can allow it to know what is precise. So that's there. Now, so far, all these things are messy. However, one thing it becomes cool is basically it does not have dash cam. I have no idea. And be mindful, yes, you can add dash cam, but again, how many of you actually do that? I do, but how many of you have dash cams in your vehicle? Another aspect, because these things will take steering wheel away from you, applying a brake. And again, sometimes applying brake means someone from behind will bam you, or sometimes something else will happen. For example, let's say somebody swerve in front of you, and your car applied emergency brake, and consequence of that is you hit into something else. Your car insurance is like, hey, all our analysis shows that you hit something. Cool. But it's not our fault, so your insurance is effed, you go to jail. Oh yeah. But if you had a dash cam, it's like, oh, somebody in front did something else. And yes, companies have tried to do that. Insurance companies, like, again, insurance scams are brutal. So for that, why you have to have dash cam. You have to. And like, I give you a real world example. However money poured into it, like, you're like, no, it's Honda, it's Toyota, they put some money, they put some research. Do they put even 1% of what goes into a jumbo jet? No. These are for jumbo jets. These puppies are designed to be like, in case of oops event, I will survive. In case of a jet fuel fire, I will survive. In case of going vabayam into the sea, I will survive. In case of going for making love scene to a forest, I will survive. And then I will tell the world what the hell happened. So next event, we can safely handle. Not having that in car. Again, imagine something random did happen, not the oops event where some wheel happened, or some animal jumped and you did swerve properly, but you did not have the dashcam footage. How would you prove it? So that, again, companies do not want it, because again, if the companies want it, that will be like, you are taking liabilities. So companies are like, no, what if we F the customer? But it's the government's job. It's like, no. You want control over people's car. No problem. Cool. Awesome. Great power comes with great responsibility. Put a goddamn dash cam. Put it in a fire brick enclosure, especially for electric vehicle, because again, those do burn hot. So something like, 2000 degrees, basically you need a good fire brick case. So the flash memory can survive for at least however long it takes for battery to burn. Without that, this is like not acceptable. Like this, not having this sort of system is not acceptable to me. Like you must have dash cam. Please add by yourself. And again, we have to demand car manufacturers to add this. Again, they can add far better, far more efficient, far like they can do much better job than whatever we can cludgeon onto it. But it has to be done. It's one of those things. It has to be done. I am not comfortable with the idea not having a third-party fail-safe. So that's the problem. That's why I'm like not that stoked about it, and especially level 3 runaway. So this was my presentation on advanced driving assistance systems. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.